Consider this video as a bonus lecture for the shopping cart application course because previously I have decided to take you directly to the architecture diagram of our shopping cart application. But before moving to that diagram, then I think that it would be better to tell you about the basic definition, what exactly is the meaning of a software architecture, and what are the concepts behind that, what are type of architectural patterns we can use when designing the architecture of any small scale software or a large scale enterprise level of applications. So this will be an interesting lecture for you guys. So now by starting this video, let's take a look at the definitions of software architecture. So first definition that says that software application architecture is a process of defining a structured solution, meaning then when we are thinking about a software architecture, so the output of that architecture would be a complete project, would be a complete working software, and that software should meet all the technical and operational requirements. That what are the requirements behind designing of a software solution, what is the domain consideration, whether we are developing a software solution for a medical hospital, or we are automating a complete school application, or a student level application, or a business level application. So what is the domain of the requirements? So as the definition says, that the structure solution that will meet all the technical and operational requirements while optimizing common quality attributes such as performance, security, and manageability. We're going to be talking about these quality attributes later in these slides. And then the definition says that it involves series of decisions, and each of these decisions have impact on the quality, performance, and maintainability and overall success of the application. So what it means that whenever you are thinking like an architect, or you are going to design a large enterprise level application, so there are certain decisions which you need to make, but those decisions will gonna have a great impact on the output of the architecture, that is the quality attributes of the architecture, which are of course the quality, the performance, and the manageability. Then there is another definition, and this one is pretty much slick definition, that software architecture is a process, and the result or output of that process is a structural solution that meets the technical and operational requirements. In order to get structured solution, software architects uses common quality attributes like performance, security, and manageability. Right. So basically, this is again the same definition, but the choice of word different, and um, it's trying to deliver a different concept about the software architecture. Now let's talk about the common quality attributes the software architecture must have. So basically, as you all knows, that if you are coming from a background of a software engineering, so these quality attributes we have talked about a lot in our education or in our professional lives as well. So these are the usability that of software architecture should satisfy this attribute, the usability, which means that how much the end product or the end system will going to be user friendly. Is the UI of the software is easy enough so that every user can adapt it, or can the system validate the common usage errors? So these are all are the part of a good software architecture. You need to take these points into consideration when you are designing the architecture of a software. Then we have maintainability, which means that how the software is maintainable, easily testable. Like if I want to add some of the test cases for my software, so does my software provide an easy support so that I can write those test cases very easily, or how easy the new developer understand the code? So the code should not be overburdened, or code should not be complex enough so that the new developers, those are coming to this product, have some kind of difficulty in understanding that what is this code written for. So the code The architecture, a good architecture must emphasize on the point that the code of the application should be simple enough so that it can be easily understandable. By it doesn't matter the new developers are coming have the good understanding of the code, or they are fresh graduates, or they have a little experience or more experience. So wherever whatever the background of a software developer, he should understand the code very easily. So this is another attribute that a software architect have to take into consideration when designing the architecture of software. And how easy to add new functionality and new modules in the existing software. So this also is the point of maintainability. If we have designed a software and that is not easy to maintainable, which means that if we want to add some new modules in our existing software, so it is very difficult to add a new module, then what is the purpose of developing the solution? So through this way, the our application will gonna be flop in future. So a good architect must need to consider these possibilities, these quality attributes. Then the third attribute is scalability, which means that whenever the a number of users increases, those are using your software product. So does your software product have the ability to work and in the same performance or in the same quality that it is working before for 100 users or for 100,000 users? Isn't it going to crash when the number of users increases? So, or is the software is architected in a way that to accompanying the increased number of users, that's the same point. So scalability all is the quality attribute that is basically focusing on how stable your system is when we will increase the load of the users. Then comes the fourth point, which is the availability, that what is the system uptime. I mean, if the website is up on the internet, and if the website is running, so it should have a perfect infrastructure background, so that the website should be running 24 hours a day. And if you are maintaining some kind of you are running some kind of website maintenance, so what is the downtime, what will be the downtime of the system, and will the downtime will be already scheduled for the website, or the or the software desktop application, or whatever the software you're going to develop. So availability, how the software is going to be available, and how for how much time this software is going to be available. So this availability is another quality attribute. Then comes the extensibility. Can the system extensible or flexible enough to incorporate additional changes? How easy to add additional modules? Can developers take leverage from the system to add more modules without accessing the source code? Does system provide inversion of control design pattern? So inversion of control design pattern is for the dependency injection, but it is also can be used for the extensibility point of view. So the extensibility is the most interesting feature, which in if you have some of you guys have looked at my previous course, the MEF, Managed Extensibility Framework. So MEF is basically a framework of extensibility. If you want to design a software product that is extensible, that provide the feature of extensibility, so dependency injection or inversion of control design patterns will be most important to consider with. Then comes the security. Does the system provide role-based security to access the system, or the code access security is in place? The code access means that web APIs using authentication tokens. So some of the web APIs should be authenticated to the particular users, and some of the web APIs are not. So all of these points should be considered or taken care at the time of when you are designing the software architecture. Then in the last is the portability. Can the data be migrated to another system, or the cross-browser support is added? Like if the website is running on the Google Chrome, that it should be run exactly in the same way on Internet Explorer or Microsoft Edge or Opera browser or Macintosh Safari browser. So this is also an important point, the portability that the software architect should need to consider. And then in the last, we have a cross platform support. Is it the requirement of our customer to so that we design a software that can run over the Linux operating system, or the Windows operating system, or the Macintosh operating system, or whatever the operating system we are talking about. So this is also another important attribute which we need to consider whenever we are designing the architecture of the softwares. So these were the some of the quality attributes. Then comes the software architectural patterns. So basically, what are the software architecture pattern or the architecture style more precisely? So there are different architectural patterns, and we are not limited to use only one pattern in one software design. So all of these patterns can be used as a combined in when designing the software architecture of an application. So now let's so basically there are these software architecture patterns are categorized. So first category is communication. That service-oriented architecture and message bus architecture styles are grouped in the communication category. Then the deployment. So client server architecture, N-tier or three-tier architectures are basically the deployment architectures. And then we have a domain. So domain driven design or domain driven architectural style is basically belongs to this domain category. Then we have a structure like the components base architecture or object oriented architecture or layered architecture. So all of these styles belongs to the structure category. Now let's talk about these individual architectural styles. So first, the client-server architecture, which is the deployment architecture. And what it says that isolate or divide the system into sub-web systems, right? So basically the client that is making a request to the server and server is the one software system that is responding back to the client. So all of the websites nowadays are all automatically developing in the client-server architecture. The website running in the browser is basically a client, and the server running on the back end or a web server is basically a server that is the second architecture, second component. So this is the client server architecture style. Then we have component-based architecture. So what it says that decomposes application design into reusable functional or logical components that expose well-defined communications interfaces, which means that if we are breaking down our need or our requirements into smaller chunks or smaller components, and all of those components are combined together to perform a bigger task. So that architectural style is termed as component-based architecture. Then we have domain driven architecture. So it belongs to only to a particular domain, or this architecture can be used on the middle layer or the business layer, because the purpose of this architecture style is to modeling of business domain and define business objects based on entities within that business domain. So for example, you are developing a software for a hospital management system or developing a software for specific doctors. So the domain which will be focusing on will be the medical domain, and definitely the business layer which you're going to design only include the entities or the objects or the classes those, and that in turn will contain the functionality that is specific to the medical domain. Similarly, if you are designing an architecture for a lab management system, all of the laboratory tests which are going to be executed, or the processes which they are following in that their lab is going to be added in this. So our domain will going to be the science, laboratory sciences. Then we have a layered architecture. So layered architecture means that partition the concerns of the application into stacked group layers. So stacked group layer mean it is a last in first out LIFO structure, which means that every top level layer can only communicate with the layer beneath it, or the second level. Then the second layer can only be communicate between the third layer or the top one, right? So the communication between the layers is very much strict in this layer based architecture. So it doesn't matter how many layers you are going to define, but all of the layers are added on the top of each other, and they are forming a stack data structure. Then we have a message bus architecture. So this is an architecture style that prescribes use of software system that can receive or send messages using one or more communication channels, so that applications can interact without needing to know specific details about each other. So uh, this is related to again some kind of a chatting system or a chat application which you have designed. So whenever you are sending a message to a group of people, so it doesn't so all the interaction between the different software components are being done by the messaging system. So Microsoft framework as a signaler is a very good example, which have to consider in this message bus architecture. Then we have n-tier or three-tier architecture. So basically, this is the same as the layered architecture, but there is a slightly different. In the three-tier or n-tier architecture, the concept is the same, that the different layers of functionality has been put in place, like a presentation layer or a business layer or a data access layer, and you can add as many layers as you want. So like the onion architecture is a new architecture style or technique in which the layers are infinite layers. You can add 3, 4, 5, up to 10, up to 20, up to 100 layers of functionality, but depending on the requirements. But there is a specific point which you need to consider in tier based architecture, that the layers or can be added to a physical system. Like one server is residing in a US state, or one is residing in some England, or other is residing in China, or India, or somewhere in the world. So basically the tier means that physical existence or the physical system will be separated. So that's the only difference. Otherwise the communication between the layers can be strict. But we'll talk about the communication between the layers, whether to keep the communication strict or not, in our when we'll talk about the architecture diagram, and it has certain benefits to that. Then we have object oriented design pattern, or object oriented architectural pattern. So a design paradigm based on division of responsibilities for an application or system into individual, reusable, and self-sufficient objects, each containing the data and the behavior relevant to that data. So this is another architectural style, that all of the software components are following the object-oriented design pattern terminology, or all following the rules and regulations of the object-oriented programming, like inheritance or polymorphism or data hiding. So any of the architecture that is being developed based on the object-oriented design, architectural design, will gonna follow all the same patterns which object-oriented programming supports to. Then we have a service-oriented architecture. So they basically, this is also refers to as SOA, service-oriented architecture, and it refers to the application those expose and consume functionality as a service using contract and messages. So WCF is an example. WCF services, Windows Communication Foundation services, are basically the example of a service-oriented architecture. Similarly, web APIs is also a good example of the service-oriented architecture, that we are adding our services of limited functionality to our software component, and those services are getting exposed at different layers. So these are the architectural patterns. So as I have said before, and again I'm saying, that we are not limited to, or we are not strictly we do not have to follow strict rules whenever we are designing the architecture of software, to follow only one style, but we can combine these styles. For example, if we are designing a website, so websites are already following the client server architecture. There's a client and there's a server, and then on the server we can also divide the layers. The application on the application logic on our server can be divided into different layers, like a presentation layer that is responsible to render the HTML, or a business layer, or a data access layer. So we can combine these architectural patterns into one pattern or one customized solution in order to fulfill our needs or our requirements. So whatever we want, we can do that. So this is not limited to only one architectural style. So that's it for a brief introduction about the software architecture. What does it mean? What is the definition of software architecture? What are the quality attributes which we need to taken into consideration whenever we are designing the architecture of software, or what are the architectural styles and patterns? So now in the next video, we're going to take a look at our architecture of shopping cart application.